So the first question is, which of the following is not a type of processor scheduling? So I will refer to the slides. We have long-term scheduling, medium-term scheduling, short-term scheduling, and I/O scheduling. So the answer is C, priority scheduling.
Question 2 is, what is the main goal of short-term scheduling? So based on the slide, short-term scheduling is actual decision of which ready process to execute next. So we can say that it determines which process will be executed by the processor. In the question, the answer will be A, which deciding which process to execute next from the ready queue.
Question 3, which scheduling algorithm is also known as FIFO? So we refer to the slide. FIFO is also known as first come first serve. FIFO also is a strict queuing scheme. So the answer will be B, first come first serve, FCFS.
In a round-robin scheduling algorithm, the key parameter that determines how long a process runs before being preempted is called the time quantum.
A scheduling policy that ensures that longer processes do not starve by increasing their priority over time is called highest response ratio next, which is HRRN.
For fill in the blanks question, the first one, the scheduling policy that selects the process with the shortest remaining execution time is called shortest remaining time. Shortest remaining time, which is also called SRT.
Now moving on to the next question for matching question. Match the following scheduling algorithms with their characteristics. So first is HRRN, which is highest response ratio next. It is the characteristic is selects process based on highest response ratio. And for the next scheduling algorithm, which is feedback, it uses dynamic priority adjustment. Then the next one, which is FCFS, first come first serve. It uses the characteristic is processes are executed in the order of arrival. And for the next algorithm, which is round robin, it uses a time quantum for preemptive scheduling. And for the last one, SPN, shortest process next. The characteristic is select the process with the shortest service time. Moving on to subjective question for question 1. In union processor scheduling, the execution of each scheduling policy is based on their selection function and decision mode. For 8, what does it mean by selection function? Selection function is the factor used to determine which process among ready process is selected for next execution.
Question 1B, What does decision mode mean, and explain two types of decision mode. So decision mode is the instance in time at which the selection function is executed. The first type is non-preemptive decision mode, which means that once a process is in running state, it will continue to execute until it is terminated or if it is blocked while waiting for I/O or other OS services. The next one is preemptive decision mode, which means that the process currently running may be interrupted and moved to ready state by the OS depending on various situations such as a new process arrives or an interrupt occurs.
C. Explain about the selection mode and decision mode for each of the scheduling policy below. The first one is first come, first serve. So the selection mode for first come, first serve is that the process will be selected based on the arrival time. The decision mode is non-preemptive.
Next, we have shortest process next. During shortest process next, the selection mode for shortest process next SPN is that the process with the shortest service time will be selected. So the decision mode for the shortest process next is non-preemptive.
shortest remaining time, the selection mode will be the process with the shortest expected time, and the decision mode is preemptive.
Okay, next for the highest response ratio next. The selection mode for HRN is the process with the highest or greatest ratio will be selected. The decision mode is non-preemptive.
Okay, so next is the round robin, which is the selection mode for the round robin is that the process will be selected after first come, first serve after each time quantum. So the decision mode is preemptive. The selection mode for the round robin is that the process is selected as first come, first serve. After each time quantum. So the decision mode is preemptive.
So for the next question, which is feedback. The selection mode for feedback is the same as FCFC, where the process is selected based on arrival time. The decision mode is preemptive. The selection mode feedback is same as FC. Where the process is selected based on arrival time. The decision mode is preemptive. Next, we got the algorithm question. So the following table shows a set of 4 processes with their arrival time and burst time. So we need to draw the scheduling diagram and find the average time waiting for the processes above using the scheduling algorithm below. First, we got the first come, first serve. So in the diagram, in the process A, the service time is 5 and the arrival time is 0. So from 0 until 4, the total will be 5. And that's for the process A. So for the process B, the arrival time for process B is 1. Since for process B to get executed, we must
wait until process A stop. Process A stop at 4 and the service time for process B is 4. So process B will start at 5 until 8.
So next is process C and the service time is 8, so it will execute for 8 microseconds.
Was kita nak retake ke?
Critic. So next is process C and the service time is 8, so it will execute for 8 microseconds.
So for the next process, which is process D, since it has a service time of 6, it will take 6 microseconds to be executed.
Okay, so now all the process has executed. So we are going to complete the table. So for process A, the start time, as we can see here, it starts at the same as arrival time, which is 0. Okay, and the waiting time is also 0. Okay, so for process B, we can see it starts, it's supposed to start at 1, but we let the first process continue first and it starts at 5. Okay. And then the waiting time, how to calculate the waiting time is the start time minus the arrival time. So 5 minus 1 equals to 4.
So for process C, as you can see, the start time is at 9. So to calculate waiting time, we just minus start time minus arrival time. So 9 minus 3 is 6.
So for process D, the start time is 17 and the waiting time is 17 minus 5, which is 12. The average waiting time is the waiting time of all the processes divided by the number of processes. So in here it is 4 plus 6 plus 12 divided by 4, which is 5.5.
Okay, so for the next question, it asks us to draw the scheduling diagram for the shortest process next, which we need to select the shortest service time and execute it first. Okay, so as we can see here, we first started at the process that arrived first, which is process A. It starts at 0 until service time is 5.
Now since it is the shortest process next, we will select from the processes which has the shortest service time. Based on this, we can see that B has the shortest service time, which is 4. So we will execute process B first.
So next, the shortest service time is 6, which is process D. So we will execute that. So that's 6.
So next shortest process is C. With a total of 8 microseconds of the service time.
So now I will complete the table. For process A, the start time is 0. So the waiting time is 0 minus 0. For process B, the start time is 5. And the waiting time is 5 minus 1, which is 4.
For process C, the start time is 15 and the arrival time is 3. So waiting time 15 minus 3 will get 12.
So the start time for process D is, you can see here that it's 9. The waiting time is 9 minus 5, which is 4. So the average waiting time is the total of waiting time of each processes divided by the amount of processes, which is 4. And 20 divided by 4 is 5.
So for the next question for shortest remaining time. A with service time 5. Then it will B with service time 4 will go. Then now we will look at the smallest value, but since the value are same, we will prioritize the process that is being executed, which is process A. So it will be 3, and this 4 will remain 4. Then continue. The smallest value is still 3, so it will be 2. It will be 2, and the 4 will still remain 4. But now C is also here, so the service time for C is 8. And now the smallest value is still 2, so it will become 1, 4, and 8. So now, as you can see, the process A is already completed. So this is process A. And this is process A.
So here we will have process B at 4, process C at 8, and now process D comes in, so it will be 6. Based on this, the shortest remaining time will be process B, which is 4. So we will execute process B. So now here it will be 3. Here will remain 8 and 6. Then the shortest here is still 3, so we will continue process B. So here you can see process B is executed.
So now I have to choose between process C and D, which one has a shorter remaining time. The remaining time for process C is 8 and process D is 6. So process D has the shorter remaining time, so we let process D be executed. So now the remaining time for process D is 5, which is less than 8, so it will continue to execute, and process C will remain at 8.
Okay, so as we can see here, all the process has executed, and the last process that has not been executed is process C. So we continue A. So it will continue for 5 microseconds. Okay, so all the process has been executed.
So now I'll create a table for shortest remaining time. For process A, the start time is 0 and the arrival time also is 0. So the waiting time 0 minus 0 will be 0. For process B, the start time is at 5. The arrival time is 1. So waiting time 5 minus 1 will be 4. So in the process C, the start time is 15. So to calculate the waiting time, start time minus by arrival time, which is 15 minus 3, and we got 12.
For process D, the start time will be 9. And the waiting time will be the starting time minus the arrival time, which is 9 minus 5, which is 4. So the total waiting time will be the average waiting time is equals to the total amount of waiting time divided by the total amount of process, which is 12 plus 4 plus 4, 20 divided by 5 divided by 4, which is 5.
So next, the highest response ratio. The process A will start first because it got a 0 arrival time. So from here, and ended at T4 with a total of 5 microseconds.
Okay, so now to calculate the ratio, first for process B, current time is 5, the arrival time is 1. So the waiting time is 5 minus 1 equals to 4. Then the service time is 4. Then for the ratio, after calculate the ratio, waiting time plus the service time divided by the service time. So 4 plus 4 is 8, divided by 4 is 2. Then next for process C, the current time is also 5, the arrival time is 3. So the waiting time is current time minus the arrival time, so it will be 2. The service time is 8. So the calculator ratio is 2 plus 8 equals to 10 divided by 8 is 1.25. Then for process D, the current time is 5, arrival time is also 5. So the waiting time is 0. The service time is 6. So the ratio is 0 plus 6 divided by 6 is 1.
Alright, for the next process, we have to pick between each processes to see which one of them has the highest ratio. So for here, we can see that B has the highest ratio. So the next process that will be executed is B, which will take 4 microseconds, depends on its service time.
Now, after we execute process B, we will calculate the ratio for the remaining processes, which is process C and process D. So now the current time will be 9. The arrival time for process C is 5. Sana, sekali. So now that process B has been executed, we will calculate the ratio for the remaining processes, which is process C and process D. So now the current time is 9. The arrival time for process C is 3. So the waiting time is 9 minus 3, which is 6. And the service time for process C is 8. So the ratio is 6 plus 8 divided by 8, which is 1.75. Next for process D, the arrival time is 5. So the waiting time is 9 minus 5, which is 4. The service time is 6. So the ratio will be 4 plus 6 divided by 6, which is 1.66.
So now I have to choose between process C and D, which one has a high ratio. So based on this, you can see that C has a high ratio. So process C will be executed. And it has a service time of 8 microseconds. Salah lagi.
Kita mesti.
So,
Kau boleh start je daripada the theory and kita yang highlight tu yang lepas tu. Itu balik tu. Tuan. Tak, kau apa? Yang reset.
jangan dulu ni.
Tak, bawah tu kau highlight. Kau just retake part yang highlight kat atas tu.
Oh ni.
Highlight bagi yang pun. So
process C will be executed for 8 microseconds.
Since the last process is process D, so process D will start at 17 microseconds. The service time will 6, so 17 until 22. Now I'll be doing the table for highest response ratio next. For process A, the start time is 0. So the waiting time will be 0. For process B, the start time is 5. So 5 minus 1 is 4 for the waiting time.
Okay, so for the next process is process C. The start time we can see here is 9 microsecond. So the waiting time, the start time minus the arrival time. So 9 minus 3 equals to 6. So for the next process, the start process for process D is 17 microsecond. And the waiting time, 17 minus the arrival time, which is 5, equals to 12. Okay, so we need to calculate the average for all the process. We plus every process 0 plus 4 plus 6 plus 12, and we divide by the total of the process. So it will become 5.5.
Now I'll continue with round robin. First, process A starts at 0 and will get executed for 2 microseconds because the time quantum is 2. And process B comes in the queue while process A is executing. So I'll put B in the queue first. Then A enters the queue. Then after 2 microseconds, A enters the queue. Process B will also be executed for 2 microseconds. And process C comes in the queue while process B is executing, so I'll put C in the queue next.
For 4 microsecond, process A will be executed because the quantum is 2 microsecond. And then the process C will be first in queue. After process A execute, we'll have process B, and process B will be second in queue. After that, process C is still in first in queue. B. Since process C will be execute, we'll have process D. Process D will be in queue. And after that, since after B execute and C, yeah, put next record.
After A is Q, you must balik Q.
After it execute, it will back in queue. And then for 7 microsecond, it will be the same. It will be the same.
Okay, so for the next process, we can see the process that comes up first in the queue is process B. So we will execute process B for 2 microsecond for the time quantum. Okay, and then the process that comes in the list is process D and A. Okay, and then the last process that we have executed earlier, which is process C, will comes last in the queue. Okay, so the next process, okay, as we can see here, the process B has already completed their service time, which is just 4 microseconds. Okay, and then we execute the first one in the list, which is process D for 2 microsecond. Okay, and then the process that is left is only process A and process C. So
Now, as we can see, the next process in the queue is process A. So it will execute for only 1 microsecond because process A service time is 5. So we have completed process A. And here the queue will be C. And since process D completed at 11 microsecond, it will enter the queue. So next we will execute process C according to the queue. So for 2 microseconds. So now here, the process that will be in queue is B.
Now for the next process, which is process D. From the queue, process D will be executed. So for two times, then in the queue will be process C. Slash executed. Then next process C will be executed from the queue for 2 times. And now we will in the queue will be process D to complete the service time.
For the next process, process D will be executed since it's the only process in the queue. Then process C will be entered inside the queue. So lastly, we will end the process and end with process C with its the last 2 microseconds.
And then we need to calculate the average time. So process A, in the first highlighted, it start with the 0. So the waiting time is start minus arrival, which is 0 minus 0, also 0. And then the new arrival with 2 microseconds will be 2. And then the next highlighted, it started with 4. So the waiting time is start minus arrival, 4 minus 2, which is 2. And the new arrival time will be 6. The next highlighted, in process A, it started with 12. So the waiting time will be start minus arrival, which is 12 minus 6, and which is 6. And there will be no new arrival time because the services has been completed. And then next we proceed with process B. In the first highlighted, it started with the 2. So the waiting time will be 2 minus 1, which is 1. And the new arrival will be 2 microsecond. With a 2 microsecond, it will be 4. And in the next highlighted, it started with 8. So the waiting time will be start minus arrival, which is 8 minus 4, will be 4. And there will be no new arrival time because the service has been completed. Next, we proceed with process C. First highlighted, it started with a 6. So the waiting time will be start minus arrival, which is 6 minus 3, with a 3. And then the next highlighted is start. So the new arrival with the 2 microsecond will be 8. And in the next highlighted, it started with the 13. So the waiting time will be 13 minus 8. So start minus arrival.
Okay. Sama.
Minus arrival, which is 5. So the new arrival will be 15. In the next highlighted, it started with the 17. So the waiting time will be 17 minus 15, which is 2. And the new arrival time will be 19. And in the last highlighted part, process C, it started with 21. So the waiting time will be 21 minus 19, which is 2. And it ended with all the with all the service time has been completed. And then next we proceed with process D. In the first highlighted, it started with the 10. So the waiting time will be start minus arrival, which is 10 minus 5. it will be 5. And the new arrival time with the 2 microsecond will be 12. And the next highlighted, it started with the 15. So the waiting time of start minus the waiting time will be start minus arrival, 15 minus 12, which is 2, which is 3. So the new arrival will be 7. And the last highlighted process is started with the 19. So the waiting time will be 19 minus 17, which is 2. And it has completed the service time. So in the process A, the total will be a total of waiting time, which is 6 and 2, a total of 8. And then in process B, the total of waiting time is 4 and 1, which is 5. In the process C, the waiting total time is 2, 2, 5, and 3, which will be 12. So in the process D, the total of waiting time is 2, 3, and 5, which is 10. So the total average will be 8.75.
So for question F, which is feedback, we'll start with 0 microsecond. Process A will be execute at 0 microsecond. After process A execute, process A will move into second queue. After that, since process A execute, process B will be first in queue. Then for 2 microsecond, process B will be execute. Belum. Process A will remain in the second queue. And then for 3 microsecond, process C will be added in first queue. For the next process, we will look at RQ. We will prioritize RQ1, which is process C. So we will execute process C for 2 microseconds. So and B here will straight be in the queue in RQ2. So here, process D will be executed, but it will be at RQ1. So we'll prioritize process D, and it will be executed for 2 microsecond. And here automatically process C will be in the next queue, which is RQ2.
Okay, so for the next process, since process A is in the queue, it's first in the queue, process A will be executed in the 8 microsecond. Then the remaining will be so for the 9 microsecond. Oh, ada. Yeah, wait. Sekejap. Sama aku buat balik ya. Okay. For the 8 microsecond, process A will be executed since it's first up in the queue, and it will only execute it once since it is in RQ2. And And then process D is added in the queue. So since process D is already executed in 7 microsecond, it will add back in the RQ2. So for the 9 microsecond, the next processes will be executed will be B. And so now that's the only processor is left in RQ2 is C and D. And processor A will be added in RQ3. So for the 10 microsecond, the process that will be executed will be process C. And then process D will be left at RQ2. And process B will be added in RQ3. For 11 microsecond, process D will be executed and process C will be added in RQ3.
Now at the 12 microsecond, we will execute process A since it's the first in the queue. So now the queue at RQ3 will be B, C, and now D since it was executed before this. And then next we will execute process B. And now the queue will have C, D, and A. Next we'll execute process C. And now the queue will have B and A. Now we'll execute process D. This good here. Now we'll execute process C. So the queue will have D and A. B is no longer in the queue since it has completed its service time of 4 microseconds. So next we'll execute process D. And the queue will have A and C.
And then next in the 16, process A will be executed. So process C will be in the top of the queue, and process D will be also added in the queue. And in the 17, process C will be executed. So only process D will be remain in the queue. And in the 18, process D will be executed. And in the queue, process C will be added back to be processed.
After process D is executed, it will enter the queue. So now we execute process C. And then it will enter the queue. So then we execute process D. And it will not be in the queue anymore because it has completed its service time, which is 6 microseconds. Then, so lastly, process C remains, so we will execute the remaining service time, which is 2 microseconds.
Okay, so for the last step of the process is we need to fill in the start time, waiting time, and the arrival time for each of the part. So for process A, the start time which actually the arrival time. So it will be 0. And then the waiting time is also 0. Okay, and then the arrival time for process A is supposed to be 2, but here, but it actually starts at 8. So the waiting time, the start time minus the arrival time becomes 6. Okay, and then we continue. So it is supposed to arrive at 9. So the arrival time is 9, but it actually starts at 12. So the waiting time, 12 minus 9 equals to 3 microseconds. Okay, and then the arrival time is 13. And the actual start time is actually 16. So the waiting time equals to 3 also. Okay, so now the process A has completed. Then we continue for the process B. So for the process B, we can see here the start time is 2. So the waiting time is the start time minus the so the waiting time, the start time minus the arrival time equals to 1. Okay, so you can see the arrival time is supposed to be here is 4, but it actually starts at 9. So the waiting time becomes 5. Okay, and then the arrival time is 10 here, but it actually starts at 13. So the waiting time is also 3. Okay, and then the arrival time is 14 as it should, but it's okay, and then the last is the arrival time is tak ada dah. Uish, hebatnya macam ni saya dah boleh ingat. Hebat dah. Okay. Okay, so the process B has complete. Okay, and then process C, the start time is 4 microsecond, and then the waiting time is 1. Okay, and then the arrival time for the next is actually 6, but the start time is 10. And then the waiting time comes 4. And then the arrival time is 11, but the actual start time is 14. So the waiting time is 3. And then the arrival time is supposed to be 15, and it starts at 17. So the waiting time is 2. Okay, and then the arrival time is 18. And then it starts at 19. So the waiting time is 1. Okay, and then the arrival time is supposed to be 20, and it starts at 21. Okay, and then it completed. So the waiting time here is 1. Okay, so for the last process is process D. So the start time is 6. And then the waiting time is 1. Okay, and then it arrived at 8, but it starts at 11. Okay, and then the waiting time is 3. And then it arrived at 12, but it starts at 15. So the waiting time is also 3. And then it arrived at 16, but it starts at 18. So the waiting time is 2. Okay, and then it arrived at 19, but it actually starts at 20. So the waiting time is 1 microsecond. Okay, so here complete all the process. So we are going to calculate the total for each total time for each process. So the first one is 12. Second one is 9. Process C equals to 12. And process D equals to 10. Okay, so we are going to calculate the average with plus 12 plus 9 plus 12 plus 10, and then we divide by 4. It equals to 10.75.